So in tonight's homework, students are going to be thinking about taking improper fractions and decomposing them to make a whole number and then the remaining fraction part. So to figure out the whole number, one of the things we've been practicing in class is thinking about how many make one whole. So if students know, for instance, if we look at letter B, we can see that we have fourths. So this is going to inform for us how many make a whole. So one whole we know would be 4 fourths. So students are going to skip count till they get close to the number they see. So 4 fourths is 1 whole, 8 fourths is 2 whole, 12 fourths is 3 whole, and then 16 fourths would be 4 whole. Well, that's too big. So we want to go back to 12 fourths. And the reason is a student should be able to understand that 4 fourths, 4 fourths, and 4 fourths, if we add those all up, we get to 12 fourths. And that's the same as 3 whole. We can see here this is 1 whole, 1 whole, and 1 whole. So thinking about adding all those up to make a total of 3. So students are going to take out the 12 fourths, and then what remains from this original fraction of 13 fourths would be 1 remaining fourth. We always want these two numbers that we make from the number bond to add up to this original fraction that we started with. So once students are able to see this breakdown of the fraction, they can then create this whole number like the model in number A. So we know these two things added together will equal, we take this 3 whole from over here plus the 1 fourth. So I'm getting the 3 whole from here and the 1 fourth from here. And then the final stage is just to combine those into the fraction. I'm going to move it just up here just so I have a little bit more space. So that would be 3 and 1 fourth. So that's what students would need to show to make the understanding between the number bond and taking out how many whole, keeping it as an improper fraction. The work that I'm erasing you can obviously continue to do and leave on the paper. The last part is for students to be able to visually see this on a number line. So if I think about what I got in my answer, I know I'm going to go to 0 to 4 because I'm over 3 whole in my answer. And then I'd write in the 1, the 2, the 3. And what students are going to want to do, like you see in this example here, they're going to want to break each whole number into the unit of the fraction. So in this case, the unit of our fraction is fourths. So that means we're going to need to include the fourths here. So here's 1 fourth, 2 fourths, 3 fourths. We know 1 whole is 4 fourths. Then 5 fourths, 6 fourths, 7 fourths, 2 whole is 8 fourths. 9 fourths, 10 fourths, 11 fourths. We figured out that 12 fourths was 3 whole. And then 13, 14, 15, and then 16 fourths is 4 whole. The number line may be a better place for your student to start if they're more of a visual learner. Then we want to show exactly what we had here. So we said we know that 12 fourths is the same as 3 whole. So we're going to make that jump from 0 to 3, and that's going to represent our 12 fourths. And then we just went 1 fourth more, so we're going to show that as 1 fourth. And this dot that we ended up at is 3 and 1 fourth. So watch that video for this part of the video for part C and part D. That should help your student work through the front of this page. Actually, it's going to be C through E. They would use the same process. Remember that we're always thinking about how many make a whole based on the denominator. So that's going to help your student determine how many go in a whole, and then continue to skip count till you start matching the number in the numerator. We don't want to go over, but we can stay under and then use the remaining part of the fraction as part of the mixed number. On the back, what students are going to want to do is also something we worked on in class, and this is using fractions, again, back to mixed numbers, but we're going to be using multiplication in this example. So I'm going to show you on B, and this should help you and your student, and this is, again, something we did for the first time in class today, so they may need some support. So we want to think about multiplication the same way we kind of did in the first part of skip counting to get up to the number. So we always want to use the same denominator that we see in the problem. So in this case, it's going to be halves. So we want to say to ourselves, how many halves can we make from 13? So if we skip count, we can say 2, 4, 6, 8, 10, 12. And if we think about how many times we skip counted to get to 12, it was 6 times. Well, 6 times 2 is 12. So that takes out from here 12 of the 13 halves. And we're representing 12 by using this multiplication problem. But because we didn't use all of it, we still have 1/2 left. We're going to want to put that as the second component. So this represents the whole number, and this represents the remaining fraction of the mixed number. So we want to be clear about those two things are separate. And then we want to convert this number here becomes the whole number. So we want to say, well, how many is 6 halves? Sorry, 12 halves. So we want to say to ourselves, well, 12 halves is 6 whole, because we want to think about what is 12 divided by 2. It tells us it's 6 whole. So we would have 6 whole and then plus half, which is equivalent to 6.5. So again, the part of the number line is really helpful for your student to visualize. I'm just going to move below this so you can still see my remaining work and be able to know where that is. So when we think about this, we're getting out to 6.5. So I'm going to make this number 7, this number 0, and then I'm going to add in the remaining 6. The thing about number lines is sometimes they're hard to get everything right on there. So as you can see, I have my number line and I'm using whole numbers first. The next part, similar to what you see up here and similar to what we did on the front, we need to break each whole number into the unit of the fraction we see. So in this case, we know we're breaking it into half because our denominator is 2. So this is 1/2. 2 halves would be the 1 whole, 1.5, 2 whole, 2.5, 3 whole, 3.5, 4 whole, 4.5, 5 whole, 5.5, 6 whole, 6.5, 7. So those blue dots represent the unit of our fraction. So we have 13 of those. So yesterday what we practiced is going kind of half by half and showing that jump. But as you can see from up here, we want to show the whole. So we're going to make 6 jumps here of 2/2. So this jump from here to here is worth 1 whole, or 2 out of 2. This is worth 2 out of 2, 2 out of 2, 2 out of 2, 2 out of 2, and 2 out of 2. And as you can see, that got us to 6 jumps and got us to our 6 whole. But then remember, we have that half a jump left, and that brings us to 6.5. So students should be able to show the whole number 6 times 2, which is showing we're making 2 jumps of the half. So I'm including that there. Students would do the same process for 18/4. On number 3, they're going to convert each fraction into the mixed number using the same practice, maybe without the number line. If your student needs a number line, just grab another sheet of paper to do that. So we want to think of, again, part of it with your student would be to think about multiplication. So 3 times some number is going to get us close to 14. So your students can, for that part, skip count. So 3, 6, 9, 12, 15. So 15 is too high, so we go back to 12. So if we skipped counted by 3, 3 times what is 12? The number that should go there is 4. So what we've done here, when we put 4, is we've taken out 12 of our thirds. So if we have 14 and we took out 12, because this is representing those 12, we have 2 left. So we want to show that with plus 2/3. And again, this number over here is going to tell us how many whole we have. When we see 4 times 3, this is actually 1 whole, 3/3. So this number is going to tell us how many we have as a whole number. So in this case, we have 4 whole plus 2/3, or 4 and 2/3. So students are going to continue to practice that. So here, one way to set it up for your child is to say, think of how many times 4 is 17, and then the remaining fraction can go in that addition model. So here we'd say to ourselves, well, 4 times what is close to 17, or skip counting by 4s. Both ways are totally appropriate. It's going to be 4 because 4 times 4 is 16. Well, if I've used 16 of the 17, I must have 1 remaining. So again, because I know this is 1 whole, I can see this is how many whole I have. I have 4 whole and 1/4. So students can continue to work on those with the support. And again, like I said, I think if you want to set it up by reminding them it's going to be times. The reason that I am showing every time here is thirds, here is fourths, here's fifths, and why I'm doing that is because I'm looking at the denominator to determine how many make 1 whole. So if that was a little confusing, that's the reason why.